Hello everyone. So today in this video, let us discuss about potential as function of electric field. So before going for that, let us define what is potential. Right? Let us define what is potential. Now, let this be the reference point. From infinity, we have to bring a unit positive charge towards the reference point. Now here, against the conservative field, right? Against the field, we have to bring this unit positive charge from infinity to the reference point. For that, we have to do some work, right? So that work done in bringing the unit positive charge, that work done in bringing the unit positive charge from infinity to the reference point against the field, we define as electric potential. Work done in bringing a unit positive charge from infinity to the reference point. Similarly, if we take any 2 points A, B, then we define this as potential difference. We have to move the charge from A to B, right? So now the potential let B VB and at A, VA. Then we define this electric potential in terms of potential difference. It will be correct method if we take the potential difference only. Okay. So now this is nothing but the potential difference between any 2 points is nothing but work done in bringing the unit positive charge or in moving the unit positive charge from A to B. This is the definition of potential. Now let us go into our topic. For that, let us take an electric field in such a direction, downward direction, formed by some stationary charges, right? Electric field direction is pointing downwards, formed by certain stationary charges. Okay. So now I'm considering a point A in this electric field. Now let us take a test charge Q0. Q0 test charge. Right? Test charge Q0 at point A. Right? So now, electric force, this electric field will exert certain force on this test charge. So that electric force exerted by electric field on test charge Q0 at A, what we will write? Q0 E. From where we got? Electric field is nothing but force experienced by unit positive charge we defined in before videos. Force experienced by unit positive charge. So electric force is equal to electric field into Q0. Alright? That is equal to Q0 E. And the direction of this Q0 will be in a downward direction along the electric field. The direction of Q0 will, the direction of this force Q0 E. The direction of this force Q0 E will be along the direction of electric field pointing downwards. Right? Now next what we have to do is, by using some external agent, now move this Q0 from A to B. Against the field direction is in downward direction. Against the field in upward direction, we are moving the charge Q naught up to point B by using some external agent. And the force here will be minus Q naught E. Why minus? Because against the field we are going. Electric field direction is in downward direction and we are moving Q naught in upward direction up to point B. So the electric force will be minus Q naught E at point B. Right? Now here, in order to move this Q naught from A to B, some work has to be done. So the work done in moving the Q naught from A to B, the work done in moving the Q naught from A to B, we write it as WAB. What is the formula of work done? Integral F dot dl. Right? Integral F dot dl. Now what is the force at B? Minus from, this is, we are moving from A to B. Minus Q naught E dot dl. Right? Q naught E dot dl. Okay. Now this can be written as minus Q naught A to B E dot dl. Right? Now only we defined potential. The potential difference between A and B points. The potential difference VB minus VA, that is equal to WAB by Q naught. So WAB will be equal to Q naught of VB minus VA. Now substitute here this in this equation, right? What we will get? Q naught VB minus VA is equal to minus Q naught integral A to B E dot dl. Q naught strikes off. So VB minus VA is the minus integral A to B E dot dl. So this is the required equation. Right? Now, if the reference point A is taken as infinity, then VA will be equal to 0. Substituting, what we will get? VB is equal to minus integral. Here we are taking A as infinity to B E dot dl. Alright, this is the potential and electric field relation. Okay, now next step. So we can define it as the potential can be written as the line integral of E dot dl. The electric potential is nothing but equivalent to the line integral of E dot dl. Right? Now next topic. So field as gradient of potential. Field as gradient of potential. Or we can also say the relationship between electric potential and electric field. Okay, the relationship between electric potential and electric field. So now we know that what is electric field intensity? 1 by 4 pi epsilon naught Q by R square, right? What is the formula for electric potential? 1 by 4 pi epsilon naught Q by R. This is electric field intensity formula. And this is electric potential formula. Right? Now put it as equation 1, equation 2. Now let us differentiate 2 with respect to R. Right? dV by dr is equal to d by dr Q by 4 pi epsilon naught R, or Q by 4 pi epsilon naught d by dr of 1 by r. The differentiation of 1 by r minus 1 by r square. So q by 4 pi epsilon naught r square. Differentiation of 1 by r is minus 1 by r square. Minus 1 by r square. Alright. But what is this q by 4 pi epsilon naught r square? Nothing but electric field. So dV by dr is equal to minus E. If r is the unit vector, then we write this as, if r is the unit vector, we write E equal to minus dV by dr r. Right? Or we write it as the relationship between electric field and electric potential. Or we write it as minus grad dr, d by dr, nothing but gradient, the grad V. Okay, so minus grad V. So this is the field as gradient of potential. So along with these videos, I'm keeping the notes in the description. So listen my videos and just prepare well for your exams. Thank you for watching my video. Yours Reshma.